What? Life is so bad. I think because of the amount of stuff. Oh, right. Of course not.
All right. I know what's going on that. All right. Okay. All right. So today I'm gonna strictly go over exercises. So I think what I'm gonna do is I'm gonna just solve them myself a little bit. And then what you want to do for the test, which is not in a while, I think it's like 3 tests from now or something, is to do it yourself as well. So part of it is some of those things I kind of told you what to do for project 1 last lecture. Some of it is about kind of being able to flexibly apply the rules, and really this just comes from practice. So, okay, I'll start with Q18, and then we'll move to kind of struct students. So what we're doing here is we want to create a block of 3 integers, and then we want a function that changes values in that block. So this will be Q18. So have my main function. So a block of integers, stdlib, stdao. So that's kind of the usual thing. So we'll just say int block. That would be like this. So if we want to change an element in the block, what we can do is we can send the address of the block and then go in there and change it. Like this. This said the first probably. Okay, so this was P block, and actually I said the name, so change R, and in location 2, we name it to change R. And I'll say P block at 2 is equal to something new. To call this, I'll say change array P block. Okay, so sorry. So this is like this. So I think there is not much that you can do otherwise here, but let's look at it in Python Tutor just to see exactly how it goes. And then we'll move on to doing the same things, but with structs. So I'm just copying this. Okay. So here, what I'm saying is get me an address where I can store stuff and store this address in pblock, right? So this address is this address. Here, what I'm saying is pass this address. So move this to the local variable pblock. So when I'm calling the function, what's happening is I have the local variable pblock that's going to be the same as this pblock. Right? So this value just got copied here. So that's the same as calling a function with an integer. You're just copying the value. It just happens that the value that you're copying is an address, which means that you can go to this cell and change it to something new. Yes, Oscar. So I tried really hard, and for some reason it doesn't work today. Let me try harder. Okay. Okay, it's not those ones. Oh, okay. Yeah. I'll switch to EC. I appear to be good at that. Okay. So, or not, because it took like 3 minutes. Okay, all right. So pblock at 2, so that's this guy. So basically I'm saying this address plus 2 times 4. So here you see that it ends with 40, here it ends with 48. And here I'm going to write to this. So just copy 42 over here. And that means that when I would try to access pblock at 2 inside main, of course, it would be 42 as well, because the local pblock and change array and the local pblock in main are the same address. All right. Is everyone good with this? Questions about this? All right. Let's move on. So let's now move on to creating students. So we've already done that, but I want to redo it so that we can then have blocks of structs. So here I have a struct student and I need a name like this. So this would be Q22. So what I'll do is I'll name this like main 18 because I need both the main function and sometimes helper functions. And then while I'm running it, it's going to be called main, and then I'll just rename it as I go. So, okay, so I need to define a student with 1,000 characters. So I'll say struct. This would be student 22. So the reason I'm naming it student 22 is just because like there's going to be other types of students in other exercises. So I just want to name this type after the question so that they don't have to like remove it. So what it asks me is to define a student. So to initialize, similarly to arrays, I can use something like this. Jennifer Actually, okay, so this is actually Roger. And then, how old is he? Probably like 41 or something. I know. So, something like that. So, okay. So, not disclosing personal information. He never told me. So, okay. So this is initialized. So now how can we change the name to Jennifer? I actually wrote those exercises before she was, I think, in practice. Anyway, so just random. So, okay. So what I cannot do is I cannot say as.name equals Jennifer. Why can you not do this? Because this is an array. If it's an array, you cannot reassign it. So you can initialize it like that, but you're not actually allowed to reassign arrays to something else. That would have been different if this had been car name like this, in which case you could say, I want s.name be the address of this J. But it's not, so you can't. So we'll do it later on. So you can initialize arrays. But not reassign. So what can you do? You can do strcpy. Okay. So what are we doing here? Let's look at what that looks like in Python Tutor. Up to 10 seconds. Okay. So too much data. Okay, so that's because it's 1000. So I'll just change it to like something reasonable. Okay. So we've created this student 22, and here's what that looks like. So we have a structure where you have a name. So you have 30 characters over here, and you have an integer over here. So what that would do is it would just copy Jennifer, I guess, into s.name, right? So the structure remained the same. It lives in the same address. It's just that you copied J over here and E over here and N over here and so on. Does that make sense? Yeah. Yeah, makes sense. So what you're saying is like, what if this were like 1, 2, 3, 4, 5 plus the null 6, and then this name is actually longer. So what would happen is this is undefined behavior because this is what we had at the end of last lecture, if you remember. You will try to write J here, E here, and so on. And then here there's no space, so it might crash, or it might be like we managed to show on Monday that actually there is a variable where you can write it, where like illegally it happens that you can write, the ICER null. So in Python Tutor, we can see, so did not crash, but it might or might not crash. So Valgrind would show you that it's actually illegal. Yeah. So here you cannot reallocate because here you just have an array of size 6. You cannot resize arrays. If it had been malloc, then you could reallocate it. So we'll get to that in a second. Make sense? So this happened to not crash, but it could crash because here we are writing, like 1, 2, 3, 4, 5. So like 1, 2, 3, 4, 5, whatever. So like phi r is being written somewhere where you're not actually allowed to write technically. Make sense? So, all right. Did not crash. Okay. So that's like this. So what are the alternatives here to copying Jennifer into s.name? Nothing apart from just doing it manually, right? So you could say something like, I want to do a manual strcpy. So just for the sake of it, I'll do, like, all I can do is just like write strcpy by myself, right? So I'll say whatever. Like this, and then I'll say, for example, I could do it like this. So, and I need to do the I++. And now I need to write the null. So I'll say s.name at I is equal to null. So that's just like re-implementing strcpy, one of the ways to do it. Does this make sense? Questions about this? All right. Yeah. Yeah. So here, SRC initially would be the capital J, meaning the address of the capital J. When we do SRC++, what we're doing is we're advancing SRC by 1, so it would be the address of the E, and then it would be the address of the N, and so on. Star SRC initially would be J, then E, then N, and so on. And here we're saying, keep doing this. So keep saying s.name at I is equal to the current value at address SRC, and keep doing it while star SRC is not null. Once star SRC becomes null, we exit. We still need to write the last null because this did not write the last null. So we write the last null. Yeah. Yeah. You could. I just chose not to. So the question is, could you do something like this? And the answer is yes. So you could do I++ SRC++. It's just that's too much all at once.
Right, but you couldn't do s.name plus because that changes like the value of s.name.
That is correct. So you cannot actually change so you cannot change s.name. So anything like this. So this was like an example of the kind of thing that you cannot do. You like nothing like this is allowed until it just would not compile. If you did star s. Okay. So star s.name you can't do. In fact, I am doing that here, right? So s.name at I is the same as right. So that is the same. So the difference is you're allowed to say the value at address, whatever, s.name plus I. So those parentheses are actually not necessary. So you're allowed to say this on the left-hand side because this is the value at address s.name, but you're not allowed to modify. Sorry, so that was an answer to your question. So so this is different because you're not allowed to modify s.name because you're not allowed to modify arrays. So you're allowed to modify the contents of the arrays, but you're not allowed to reassign an array. Just would not compile. All right. Does that make sense? All right. So that's like this. So change the age to 21. So I'm just commenting this out. This was just manual strcpy, which was in the side. So how do you change the age? That's not the problem. You can just say as.age is equal to 21. Okay, that was supposed to be a string. Okay. So that is allowed. That is different from s.name just because you can do this with integers. You cannot do this with arrays. So this is not specific to structs, right? So you cannot do something like whatever, like none of this is allowed. On the other hand, if you say int x and then you say x is equal to 21, that is allowed. All right, so that's the principle here. So that is completely fine. Does that make sense? Okay. Okay. So PS is a pointer to the student. So we are doing this. So we're saying student 22 PS is address of S. So what is this? So this is a new variable that's of type address of student 22. So this part says this is an address. This is the name of the variable. And then we're initializing it and saying this is the address of this guy. So we were also asked in the next question to change the name to Jenny. So how can you do that? So again, we need the address where the name is stored. The address is s.name. The idea here is to access it using PS. So two things you can do. So you can say either ps.name. And again, same thing. Or you can do PS arrow name. So those are the same thing. So if you remember, star a.b is the same as a arrow b. Another way of thinking about it is you need to get the name and you need to get the name of S. So PS is address of S. So basically to cancel out this address of, you do star PS. And then star PS is just the same as DS. Does that make sense? More ordinarily, I would say, okay, if it's a pointer, in order to access a field like name of that pointer, I would usually do the arrow. So to me, this is the more natural way of looking at things. But I think if you just think about it from first principles, probably you're thinking of this because you're thinking, okay, I got to get to s.name in order to be able to do something like line 28. but what I have is p underscore s rather than s. So I'll just like get to s like this and then get the name the old way. Either works. What happens is C just converts this to this. Make sense? No questions about this? All right. So we did that. So again, we want to change the integer. That's exactly the same thing. What's the h now? When? So like this, or you can do so that's just the same thing, right? So to change the h, you would just do s.h if s is of type student. Or if what you have is the address of the student, you would go to the value at address ps.h. Make sense? So I think the most natural in this case way of thinking about it, even though like those are all the same, right? But I think the most natural way of thinking about it is line 40, because if you have a pointer to a student, then just think about it like, okay, like to get at a field of a pointer to struct, you use the arrow. But again, those are exactly the same. It's just about what's more natural. Make sense? All right. So now we want to create a function that takes in a pointer and changes the name. So what we want to do essentially is, rather than do it in main, we want to send the name to a helper function, and inside that helper function, we want to do the same thing. All right. So, okay, this is Q27. So it takes a pointer to student. And it takes a name. And in here, all we need to do is just call strcpy. And copy name to name. So that's the same thing, except we send PS and name over here. So let's look at how that works in Python Tutor. So we have our change name. I'll copy the definition of stint22. And I'll write this over here. So I'll define the student. All right, what's the name that we're not using? And so that's going to be Bob. Bob is going to be 50. So let's do kind of several ways of doing this. So first I'll do what we've done before. So I can do student22 star PS is address of S. And then I'll call change name. And I'll do Alice like this. So let's think about how the calls work. So here PS is the address of this S, and this expects PS to be of type student22 star. So PS is already of type student22 star, so I'll just say PS. So the types match, right? PS is of type student22 star, and this PS is also of type student22 star. So you might probably be thinking, well, like, should this be address of? Should this be star? Something like that. And the way to think about it is, I got to make the types match. So the question just asked that changed name would take the address of a student. So this has got to be like that, and that means that you're sending PS over here. Yeah.
Yes, we just directly write address.
Yeah. I was about to do that. Yeah, you can do it. Okay. And then here, what happens is, if you have something inside double quotes, that means that it gets converted to the address of the first character, so to the address of A. So that's what gets sent. And here, you're sending strcpy, the address of the A, and you're sending the address of the name here. So I'll change this again to something short. And I'll run this. All right. So initialized over here, PS is the address of the S. So that means that PS is going to be this guy. So this just got copied over here. And now I'm copying the PS from main to the PS and change name. And I am sending the address of the A to name. So here, this guy just got copied. And then here, what I did is I also have Alice somewhere. So this is the address of the A. Would be nicer if Alice had been displayed, but it's not. And now what happened is I just copied everything from Alice to over here. So note that S was defined in line 13. So that's just a variable that has, the 5 characters and the number 50. And I wrote ALISE null to this guy. Yeah.
But instead of name, I use star name or something.
You cannot. So the question is, I think, what if this had been star name? And the answer is that would get you an error because strcpy expects a variable of type car star. Star name is of type car. So star name is the same as, so I'm just writing it as a response to the question. You probably don't want to copy it. Is the same as name 0. And those are of type car. strcpy expects car star. Yeah. Yes. So Alice is a string literal. Yes. So is Bob. So a string literal just means a string that's written in the code. So I think what you're asking is Alice really a constant? And the answer is yes. So if you were to try to modify, so because Alice is, so this is again in response to the question, is defined as a literal. You cannot modify its contents. Nor are we trying. So we're modifying the contents of PS name. We're not modifying the contents of name 0. So what you cannot do is you cannot do something like this. So I'll write it over here because that's the only place where I have the address of the A. So I cannot say like name 0 equals A. That might cause a crash. Yeah. So you can make it a constant car star, but you can also make it a car star. So that's that does not even result in a warning. You just silently convert it. So so there's two different things. So this guy is of type const car star. That is true. However, what we're saying here is we're sending it to a variable of type car star. So this is analogous to saying something like double x is equal to 5, right? So 5 is an integer, and it's of type integer, but we are assigning it to a double, and that just gets converted. Does that make sense? Okay. What's going on? So, all right. Set this. Okay, I don't know. I'm not hissing. Although it certainly sounds like okay, let me try to make. Okay. I'm not in fact a balloon that's being deflated. Might look like that. So okay. Okay, anyway. So that's like this. So we now want to create a function that takes a pointer, changes the age to 20. That's the same thing. So we can just do it like that. So the same way that we've done it in the main function. All right. All right. So we've already called this over here, and now we want to use PS. So this is actually in response to a question from before. So we want to call the function from Q28, but like you asked, I think a few minutes ago, what if we want to use address of S directly? And we can, right? So if I want to say change age, I can say PS 21. I can also say change age, address of S 21. And those are the same things, right? So we said up above, student 22, PS is address of S. So we could say PS, we could say address of S. Those are equal, right? So PS is just a number, that's the address of the S. We can say address of S directly. But one way of thinking about it is to think back about how do you change the address of an integer? Well, you need to send the function the address of that integer. So in the same way, if I want to change S, that's over here, I need to send the address of the S to the function. Right? So that's kind of the standard way of changing an integer. That's also the way to change the S. So you can send, indirectly this pointer, or you can send address of S directly, and then you change age. Yeah. Okay. That's right. So what you cannot do is you cannot let me switch back to this. So you cannot do it over here. So this name is not an array, right? This name is the address of the A here, right? So you can say PS name. So here we need the parentheses because of order of operations. This is fine, precisely because PS arrow name is an array. All right. All right. Okay. Next one. So now I want an array of 5 student objects. Let me start a new main here. So this was 22. So I can say that I want an array of students. And that is what it would look like. This is 22. All right. So same as you can have 5 integers, you can have 5 students, and those are stored in an array. So now we want to change the names and the ages of the student at index 2. So the most straightforward thing I can do is I can just say, okay, so I want to change so this would be change age, and here what I need is an address of student 2. So I can literally say that. I can say address of student at 2. Yes. Okay. So this approach is basically saying, okay, like here, what I need is an address. I know how to get the second element of an array. That's the usual thing. You just say the array at 2, that's student number 2. I need the address of that. Okay, I'll just get the address of that. What's another way of doing it? Someone else? Anyone? Yeah. Well, no, so malloc is different, right? Malloc gets you new memory space that's different from the existing array students. So I want to change, so I want to do this same thing, but I want to basically get a value that's the same as this, but in a different way. Yeah. Yeah. So what's the pointer to students 2 though? It's literally students plus 2, right? So I can do students plus 2. And similarly, sorry, students. And similarly with the name. So that would be like this. Sorry, this is not quotes. Okay. Why is that? Because students is the address of students at 0. Like that's how it works, right? So if you say the name of an array, that gets converted to the address of the first element. Students plus 2 is the address of student number 2. So another way of thinking about it is, if you remember, array of 2 is syntactic sugar for star array plus 2. Right? So that means that star address of let's do it like this. So that means that if I want the address of array of 2, that's array plus 2, because star array plus 2 would be the thing itself. Right? So here you're just saying, well, like address of and then get the value. Well, that's the same as saying array plus 2. But another way of thinking about it is just remove the star. Right? Does that make sense? So that means that I can just say something like this. I would say that I don't know which one of those is more intuitive. I think if you're just thinking about it in a forward kind of way, you would again say, okay, like change age. This needs to be of type student 22 star. So, and I need to change the value of student set 2. So just the address of that is of type address to student 22. So we'll just do it like that. Or you can think about it as, well, students gets converted to the address of the first element. So the address of element at index 2 is just students plus 2. Make sense? All right. Do we have time for one more? So here we want a malloc allocated block of 5 students. We got the number here. So this is 32. So this would be like this. And then except for size off, which in main 32 would be different, you would use this students and this students in the same way, because this is the address of the first element of the block. And when you use it, this is also the address of the first element of the block. The difference, which we'll get to after the lineage test, is that you cannot return this guy, but you can return this guy outside of main 33. All right, good luck. I will see you tomorrow. Bye.